Hello, in this video we're going to use the perfect substitutes utility function and calculate three measures of consumer welfare. So here is our perfect substitutes utility function. Consumer has income of $12, price of good Y is $2, price of good X is $1, forming the budget constraint. Income equals the price of good X times units of good X plus the price of good Y times units of a good Y. We get the following equation. And we want to calculate the compensating variation, the equivalent variation, and change in consumer surplus from an increase in the price of good X, which is currently $1, to $1.50. So before the price increase, we're going to take the marginal utility and divide it by the price of good X for each good to see which good gives the most marginal utility per dollar. And in this case, the marginal utility of good X is 4, just the coefficient on this X term in the utility function. And the marginal utility of Y is 3, again, the coefficient on the Y term in the utility function. And we see here the consumer should buy good X because the consumer gets more marginal utility per dollar for good X than good Y. And likewise with the price increase, given this price increase, it's still true that the marginal utility per dollar of good X exceeds the marginal utility per dollar of good Y, so the consumer should continue to buy nothing but units of good X despite the price increase. So the consumer will spend all of her income on good X before and after the price increase, so Y will equal 0. Let's start with the compensating variation, the amount of money to give to the consumer to completely offset the price increase so the consumer's utility is unchanged. That is, it stays on the same indifference curve. Here's our utility function, our budget constraint, and as we said earlier, the consumer will not buy any good Y, so the consumer buys only units of good X. And if you spend all your money on good X, so Y is zeroed out here in the budget constraint, so X will equal 12. So the consumer will buy 12 units of good X. And the utility at 12 units of good X and 0 units of good Y is 48. So let's set utility equal to 48. Setting Y equal to 0. Solving for X, X equals 12. Now we will get the new budget constraint from the price increase of good X to $1.50. And we're going to plug 12 in for X and solve for M. M equals 18. So the compensating variation here is going to be $6, the amount of money to give the consumer to completely offset the price increase. So in other words, this combination of having $18 and the higher price of good X gives just as much utility as having only $12 of income and the lower price of good X. So the compensating variation is the difference in M here. Now let's look at the equivalent variation, the amount of money a consumer would be willing to give up in order to not face the price increase. So we start with the following. We're going to start with the budget constraint at the higher price at $1.50. And at $1.50, the consumer would buy 8 units of good X, plugging 8 into the utility function. Utility is 32. We're going to set utility equal to 32. Consumer's not buying any Y, so once again, Y is zeroed out in all of this. And we solve for X, X equals 8. So now we're going to look at the budget constraint with the original price. That is, the price of good X equals 1. It's going to look like this. And plugging in 8 for X, 0 for Y, M equals $8. So the equivalent variation here is $4. So the combination of having $12 of income and the price of good X of $1.50 gives just as much utility as having a combination of only $8 of income and the price of good X at $1. And finally, we can look at the change in consumer surplus from the price increase. So the demand for good X is going to look like the following, just going to set Y equal to 0 and solving for X. So the demand for good X will look like this. And if the price of good X rises from $1 to $1.50, we're going to use some integral calculus here. So the change in consumer surplus, since the price is going up, it's going to be negative. So we can take the integral here over the demand from 1 to 150. Solving for the integral, which I give the rule down here, 1 over x is just the natural log of x. And now evaluating, we get $4.87. Our 3 measures of consumer welfare. Okay, that's it. I hope you found this video useful.